hopefully diving a little bit deeper into more than just what you know at a basic level. We'll be talking a little bit first, just getting basics so we're all on the same even keel there. Going into a little bit you would normally think of or that you knew were possible. Just a little bit of background on my knowledge of PowerShell and where I come from. I'm currently a system engineer at Ministry Brands, a local company here in town. We're a software development shop, among other things. I've been with the company for about 4 years. Started off there actually working with Wesley and Brandon, who were on the call, doing a lot of system engineering, not development, automation to an extent, which is I've almost become development. And I started off coming into the company with no knowledge of what PowerShell was, not ever really touching it in my life. I had some experience with .NET. I came out of Pellissippi with my degree in software engineering. So I had a lot of experience in .NET and general development from there, but I had no idea what PowerShell was. Fast forward, jumped into the internship, realized that Wesley had built 90% of the infrastructure there on PowerShell. So it was kind of a do or die. So I jumped into the middle of it. Within 2 weeks of not knowing anything about PowerShell, I was building fairly complex DNS management utilities, all within PowerShell, something I'd never done before in my life, and we're still using them today. So I think it worked out pretty well, and it's kind of a testament to how usable PowerShell can be. Let's see. So without any further ado, we can jump into the presentation. Just a little bit more about myself. Like I said, I'm currently a system engineer at Ministry Brands. Graduated with my computer programming degree from Pellissippi in 2018. Started my internship with Ministry Brands on the following Monday. Graduated on a Friday, started an internship on a Monday. While I was working on my internship, I finished my bachelor's in software development. And within a few months of getting that, I was hired on full time. Been with MB ever since here. I've got all my social information also on here. If anybody wants to reach out, feel free. I will say my website is not currently active. I'm hoping to get that deployed within the next week or so, but the email does work. So reach out however you want. And with that, we can kind of jump into the basics of PowerShell and what it is, what it can do, and how it can help you. So first most important question to ask when you're learning anything is, what is it and why should you care about it, right? So PowerShell is first and foremost an automation language. It's built to automate practically anything. It's built to be flexible, built to give you the level of control that you need without having to build everything from scratch, right? There's a large repository of information there and pre-built scripts and modules and code that you can invent the wheel. On top of that, it's also built on the .NET framework, same as C# or several other different languages, which means that you can use a lot of the DLLs and things that are built elsewhere within the .NET environment. So you can have C# code and DLLs that you'll be importing into PowerShell. And I'll actually be showing an example of that later on in the presentation. Now, with all of that, it's meant to be fast. It's meant to be used on the fly as you need it, where you need it. But there is a fallback of that. It's not as efficient as a traditional programming language. You are going to notice some inefficiencies around things like garbage cleanup, other things like that. On a day-to-day basis, you'll likely never notice it, but with larger scripts, it will begin to slow down in places where other things may be a little bit quicker, other languages may be a little bit quicker. But along with that also, PowerShell is probably the most distributed language out there now. 99%, I shouldn't say 90%, but a large portion of companies are mainly Windows, at least for end user machines, which means it gives you a huge user base to be able to deploy scripts out to without having to require any additional installations or setup. You can load a script out to a user machine and it just runs 9 times out of 10. And because of all that, it's very light, very versatile. Scripts are typically, one file, click run, and it just works. So with a little bit of background of PowerShell, I'll just do a quick sample here of what the code is actually going to look like, what PowerShell is actually going to function like. Now, some of you I know probably are already familiar with PowerShell, but this will just be a little bit of a basics to get us all on the even keel. So This is just a small sample portion of code that I wrote just to display what PowerShell can do and what it looks like. So first, just a basic variable here on line 2. Every variable in PowerShell is going to be prepended with a $sign. That's a reserve character in PowerShell, so it knows where the start of a variable is. As I also highlight here, PowerShell is a loosely typed language, meaning that there aren't strict types tied to any given variable. Meaning you don't have to initialize them first with a type and then store only the type in the variable. There are ways around that. You can make strictly typed variables in PowerShell, but by default, the language is meant to be loosely typed. There are different schools of thought on that. I prefer loosely typed because it lets you care less about the type of data and more about what your code is doing. So we move down here. This is just a basic conditional statement. This will look fairly similar to anybody who's done coding in the past, any other programming language, an if statement, still an if statement, right? The one main thing that I point out here is that these are quote unquote unique comparison operators. That took me quite a while coming in as a developer to get used to that. So you can't use double equal to compare two items and find equality. That's -eq. Also here for separators, you have -or instead of, it's different between different languages. So that takes a little bit of getting used to. It comes back to the fact that PowerShell is traditionally a shell language, so that looks more like a switch, and that's the way things kind of roll out. Now, if we move down to line 6, you can also see that PowerShell by default does support variable interpolation, which is very nice when you're writing out strings like this. So you can see this variable is a string. When you actually write this output, it would just say, you typed hello world. It makes things much cleaner and easier. And that's something, it's a trend you'll notice with PowerShell. It's making you worry less about the type of data and the back end of everything, and just let you focus on what you're doing and what you want to accomplish in the easiest way possible. And we move down here to the bottom segment of code. This is a fairly traditional thing in PowerShell. So this is called the pipeline. All we're doing here, first, we're invoking this .NET method on our variable, which toChar array. If you have some experience with .NET, will probably look familiar. Basically, it's just saying, give me the string and put every single character in the string into its own array. With that array, we're actually piping it to this for each object commandlet. All that the pipe is doing is redirecting the output for this, in this case, into the for each loop. So every single item in this array is going to iterate separately through the for each loop, passing it through the pipeline. And we can continue this pipeline on down the line if we wanted to. If we kept outputting things from the for each loop, we could pipe one to the next, to the next, to the next. There are some efficiency hurdles with that. It does slow down a little bit, but as you can see here, it makes things really easy and simple and fairly clean to read. And now with this specific example with the for each object commandlet, you also have this iteration variable. That's something that's you'll see a lot in PowerShell as well. It's $_. That's a reserved variable that, like I said, in this case with the for each object, is actually going to be your iteration variable. So that's currently the data that it's processing. So in this example, when you first run this through the pipeline, your first character passing through is going to be the H. So it would output H, and then as you write this down, it would just write out the entire variable vertically in the command prompt. So if we want to move through this, we can talk a little bit about some of the things you can actually do with PowerShell and how we can implement this in a useful way. And one of the main ways that you're going to do that is interacting with APIs. Practically anything in modern development, or even just engineering, you're going to be interacting with an API at some point in your life. There's always third-party companies, typically through a REST API, that you're going to need to interact with. You're going to need to get data out of a source. You're going to need to change data. You're going to need to do something with a third-party entity. And PowerShell has a lot of really great utilities built in pre-made for this. Mainly the two that we'll be working with are either invoke REST method or invoke web request. Invoke REST method is going to give you a much cleaner experience. If you're working directly with a REST API where it's spitting out JSON, it's going to give you much easier, to the point that you don't have to worry about as much of the back end and the actual data that's being fed back. It's just going to give you the data that you care about in a usable format that you can actually use within PowerShell. Invoke web request is going to be a little bit more in depth. It's going to let you actually see the headers. It's going to let you see the every bit of the data that's passing back and forth between you and the client, or excuse me, the server. So depending on which API you're working with, you may be able to use invoke REST method just fine. Other times you may need to dig a little bit deeper and use invoke web request. But now some of the things that PowerShell offers to make API calls easier. At the end of the day, like everything else in PowerShell, it's all written on .NET, right? So if you're familiar with any kind of .NET development, a lot of the tools that you're using there will either be used in the back end or will also be available for you to use here. And that can just make things a lot cleaner, give you a lot more compatibility with, again, different DLLs or any different things that you would need to do. Also, with invoke REST method, you will get automated JSON parsing, so you don't have to mess with anything. You don't even have to pass it through any of their interpreters. You just make a call to a REST API. If it brings back JSON, you get it in a PS custom object, which is an object that PowerShell can understand, and you can just read and iterate through. And it also, as I was saying, gives you as much or little control as you need with, invoke REST method or invoke web request. You can only change what you need to change or let PowerShell do what it can do for you. And it's also great for management APIs. So what I mean by that is anything that you need to routinely get data out of or routinely work with. A great example for us was DNS management, right? So we mainly use Route 53 for our DNS management and hosting. A great way that we were able to use that is, I'm constantly adding records. If I need to come through and add, say 30 records for some deployments happening, instead of having to go through and click through for however long that would take, I can just have one line of code, load in all the records, push a button, and everything's added for me, all through PowerShell utilizing these APIs. So talking about that a little bit, let's try to jump straight into the code, and let's make a thing. So we'll open up PowerShell here, and I just have a basic little sample here, a demo of what we could do. This specifically is using the GoDaddy API. And yes, these are real keys and secrets. I don't care if you steal my account because there's nothing in it. I created it for free. And normally you should never post actual credentials in code. This was just easier to explain at this point. But so we can walk through this a little bit first. But I think before we do that, I'll go ahead and try to just run this so you can see the output and see what it actually does. So you can see we get this output here below. And what this is doing is GoDaddy has an API that allows you to see whether a domain is available or not, available for purchase. It's super simple, super quick query, and we still get to pass some data so we get to see what that looks like. But first, we want to step through here. We just initialize two variables here, the key and the secret. These are two things that you get from GoDaddy whenever you set up an API key. That's what's going to give you access to their API to be able to make calls and do whatever you need to do. Now down here below, what we're creating here is a splat. And what a splat does, it's the same thing as going down here to invoke REST method and building out every single one of these parameters that it's asking for. But we get to do it in a much more structured way, right? Because we're not going to have all these switches coming out here going all the way across the screen, whereas we can have it one side of one hash table here and pass it all at the same time to invoke REST method. It makes it a lot cleaner when you have a lot of parameters you're passing. But so if we step through what this hash table looks like, which starts off with this @ symbol and open curly brace, that's what's going to start off a hash table in PowerShell. And we're going to step through here. The first parameter we're going to be passing is headers. And GoDaddy is pretty simple with authorization. It's still some security, but it's not the best. So all they look for is this authorization header. The header value is going to be prepended with SSO-key, your key, colon, your secret. And that'll be passed over HTTPS, so it's quote unquote secure. We'll step through the next parameter is the URI. This is just the endpoint that we're reaching out to at GoDaddy. This is basic just to get the available domains, whether a domain is or is not available. The method in this case, we're going to pass a post method because we're actually going to be giving it data back to say, these are the domains, are these domains available? And right here, you can see I'm just passing an array. In this case, I'm converting it to JSON because we want to have a JSON body that we're passing back to GoDaddy to tell them these are the domains that we want to check. it will return us down here. It will return the list of each domain, basically an object for each domain telling us whether or not it's available. And I think there's some tertiary information in there as well. But all we care about is whether true or false it's enabled, it's available. So we step down here and we actually do that. So we go through, we do an invoke REST method using our splat that we created up here, passing all those variables in. You'll notice that we, instead of using a $sign, we're using this @ symbol. And that's what tells PowerShell that we're using this variable as a splat method. So it's going to take all of these parameters, pass them back to the invoke REST method. In this case, we're doing something kind of interesting because this is, again, trying to use PowerShell typical tools. We're going to use pipelining here. So we're going to take the output of this REST method, which is going to be a PS custom object, or excuse me, an array of PS custom objects. And we're just telling it we only want to grab the domains object. So if we run this as it sits, clear the screen, you can see what the output of that looks like. So see, we get this nested object here, nested under domains. We don't care about the containing object, we only care about the data that's inside of it. So to do that, we pass the output to select object, and we use expand property. So we say we only want the domains, the contents of domains, and stored in this domains variable. So if we run that, we can now look at domains. And this is all the information that we've gotten back from GoDaddy. With this information, I've just done a quick little for each loop here. So we pass that through for each object. And we say, we print out this output text here, right? In line here, I'm using variable interpolation to do some, basically to use some calculation here. In this case, I'm just saying for the current object that I'm looking at, which would be, let's take this one, for example. I'm saying I only want the domain out of that. So I'm doing .domain. So I'm putting in, it looks like, enter domain. And then here we're doing another an if loop, doing an if statement. And we're saying if it's available, which means if it's true, then we'll say is, else it is not. So we just get those two little lines of text output. Let me run this again. It looks like example.com is not available, whereas PowerShellPresentation.com is available. Now this is a pretty basic example. The reason I chose GoDaddy is there is still some authorization there, so you can see a little bit of what how headers work, things like that, and how easy that is to pass through PowerShell. And like I said, this is a basic example, but you can see how you can expand this out easily into a function or a separate commandlet that you could just pass in a list of, however many domains, and you could see instantly how many are available and what the data is on each of those. So this is just a small sampling of all the expansive work you can do with APIs and PowerShell and just how easy it is, because in 25 lines of code, I don't even need that much with spacing. I was able to build all of this, right? And it seems simple, the output's simple, but all the things happening behind the scenes are much more advanced than it feels like. So this is all great and it works really well. But what happens if you need to have access data from a website or a service that's not accessible over an API, right? We basically need to automate the functions of an actual person. Well, we have utilities for that as well. And that's where Selenium comes in. So first off, what is Selenium, right? Selenium is traditionally a QA web development tool, not development tool, but testing tool. The reason it exists is for QA engineers to go through and test automated testing of web applications, right? So if you need to actually go through and see if you enter bad data into this field and click the next button, is it going to blow up, or are you going to get the correct error message you're looking for? In order to do all of that, you'd have to have full access over a browser window. In this example, Chrome. There are other extensions for Firefox and things like that. In our example, we'll just be using Chrome. But it gives you full control over a browser to be able to see every part of what you're looking at. And in essence, you can basically impersonate a person, right? You can go through, do those mouse clicks. You can do mouse movements if you wanted to. You can send keys and keystrokes to different text boxes. Well, with all of those tools that are available originally as a QA development tool, we can use those same things using the .NET DLLs that were already built for Selenium and PowerShell, because again, it's all built on .NET. It's all just a DLL. You can load it in just as easily. Now that we have those tools available to us in PowerShell, we can then go out and automate all those tasks, right? So now, even if a website doesn't have an API, you can still reach out to it, grab data back, store them in PowerShell, do whatever code or manipulations you need to do, store them wherever you need to do. You have access to everything. And like I said, it allows automation of non-API services. But now, along with all that, it's fair to mention it is temperamental. And what I mean by that is you don't have full control over the website, right? You have full control over the browser. You can interact with the website, but you're not the development team on the back end. When they make a code change overnight and the HTML code changes on the front end, the back end code changes when you hit a button, something else happens, you don't have control over that, and it can break your code out of the blue. I've had that happen, and there's a certain level of maintenance that goes into Selenium. So it's great for one-off utilities, saying, maybe you're doing a migration from a third-party company that doesn't want you to have your data out because they know you can migrate to a competitor. This is a great one-off utility to build just to say, I want all my data out here, and now I want to put it in this better company over here who does have an API, and I can drop all my data in. So now we have kind of a neat demo for this one. It's a little bit fun, so we'll jump into that. Let me pull up my other screen and open up that PowerShell window. Selenium, there we go. Now, this PowerShell script was born out of a competition at work, as things tend to be competitive at work. So I'm sure you've probably all seen the words per minute typing testers online, right? They were, I think, born out of the 90s. Now they're all web hosted because the cloud. I'm not a fast typer, despite being a developer. I'm not a fast typer. I type maybe best case 40 words per minute, and other people at work were blowing me away, and that made me not happy. So I used the tools that I did have available to me to blow them out of the water, somewhat illegally. So if we step through this code, I'm going to first explain what's happening behind the scenes, and then we'll get to see all the fun that happens at the end. First, all we're doing here is we're adding this add type commandlet. Basically means loading in a DLL, right? So you already have a DLL sitting there. You want to be able to access the classes that are inside of that. You add type. Now all those classes are accessible to you within PowerShell. This WebDriver DLL comes directly from Selenium. It's accessible over NuGet. You can just pull it down from .NET. And right now I have them all sitting in the same directory, but you can move them wherever you need to. Going through here, we're just initializing all of the stuff that we're going to use for Selenium. In this case, I'm not using it in headless mode, but you can. That's what all of this line does here in line 6, hide command prompt window. You can hide the window. I'm currently not in this example. Let's see, if we step down here, we get this driver variable on line 12. That's what's going to be the main use case and what we're going to be using throughout the script, because the driver is actually the Chrome window running in the background. That's what you're going to be interacting with, and that's what's ultimately doing all of this for you. So if we just run these first lines, you'll actually see the Chrome window appear. I have to move it over to the correct screen. So now we have an open Chrome window, right? Looks normal, no issues, but you see this little warning at the top: Chrome is being controlled by automated test software. That means that now we have full control and full access over this Chrome window to do anything we want to, read anything, redirect from there. First thing we're going to do is actually go to the website. So by setting the URL on the driver, we see that the URL actually changes. This is actually a fun new thing that they implemented cookie software, or this cookie warning. So to get around that, first, because we can't access the site before we do that, we have to find this button in code. And the way that we do that is by finding on the HTML element for the button. So if we do inspect, you see there's a very long, very unique ID. I prefer to use IDs, but in theory, they're supposed to be unique throughout the web page. And that's what we're going to be using to uniquely identify this button. So if we go back to code here, I'm making a call out to the driver to say, find an element by the ID. This is the ID. And we're going to be storing that back in this allow cookies button variable. I have this wrapped in a try catch just in case the page hasn't loaded yet or they went away with this error. We don't have to worry about it anymore. Now we're saying if that button does exist, all we're going to do is click it. And this is just a quick, easy method off of that button variable. And we're going to click that button. So first I'm going to populate the variable. So now we know what that is. And you can see what that variable looks like. It's just some basic metadata on it. It's the position on the page, things like that. And we go down here to line 25. We run that, we click it. Now you can see it disappeared because we clicked the button. We didn't click the button, the code clicked the button. And now the next thing we're going to do, so first I can explain exactly what the page does. So you click in here, you type exactly what you see in the gray highlighted area. You hit spacebar, it advances to the next word, you type in that word, spacebar, next button, next word. It goes from there. Now that's a pretty simple thing to automate in theory. If we want to look and see, okay, what's actually in here, what type of element is each of these words, we right click and inspect directly on that element. You can see these are all in a containing div of called row 1. Row 1 is going to be your containing object. So all I would need to do is say, all right, let's look for the first highlighted span, because that's going to be what's currently highlighted. That's what it's going to be currently looking for. So that's what I'm doing down here. So we're getting first the word count to know how many words are going to be in this giant list of words. We're going to be doing that by saying find the element, row ID, and then we're using this to find all the, wrong button. Then we're using this find elements on that element to find all the child elements of it. You're finding every single span tag. From that, we're just wrapping this all to get the count. The reason we want the count is we want to know how many words are in there and how many times we need to iterate over the current word. And you'll notice that every time the word updates, the highlight class moves to the next span object. With that being the case, we know we only need to iterate however many times, however many words there are, right? So if we run this, for example, we check our word count. We're at 389 words. So that's how many words are waiting in the queue for you to type. And that's how many times we need to iterate. So we just built out a simple for loop here to say we're going to run this 389 times. And this code that we're running is going to first find the input field, which is the text box that you're actually typing in. And to that input field, you're going to send the following keys. The keys you're going to send are the text value of the current span tag that has the highlighted class on it. So that's going to be, in this case, away is the word. We're going to output that, and we're also going to output this, which is actually space. I forget what ASCII character represents space, but just prepending that to the end, so it sees a space and advances on to the next. The backend code for the website sees that, advances onto the next word, moves the highlight class onto another span, and then the whole process repeats. So let's kick off this process, and we can actually see it run in real time. You can see it typing, and you can also see each of these expanding and moving down the line for the highlight class as we go. Let's see. I think my clicking may have broken something, so we'll start that back over real fast. Run this from the top. As I mentioned, Selenium is temperamental. All right, let's see. Stop the process here real quick. And I will run that again. And there's a new Chrome window. And then we'll repopulate all of this to get our word count back. And now we're off and typing again. And you'll notice it's actually happening so fast that the UI can't even update quick enough to show the word in the text box before it passes on to the next. So I have a good feeling we'll probably be at a pretty high words per minute. And you'll notice the only slowdown at this point is just the code in the website itself to keep this from going instantly out. So we're going to
how does Chrome memory usage look when you do something like that? Does it kind of spike out, or?
It's actually not bad because it's the same as if you had this Chrome window open yourself typing in it. So if let me see, look at Task Manager here. Chrome. So currently we're using 978, but Chrome is RAM hungry, and I'm also sharing my screen and have Canva running. But all in all, that's about what you'd expect for Chrome to actually be running.
Cool.
And what you'll notice here too, so they know we're too fast, right? No human could ever actually type at 398 words per minute. And I accept that. I don't want to break their website. So we'll let that advance on, but you can see what we actually got. They won't say our scores because we know we're hackers, but we still get to see that we actually did something quite cool. So we got the 100% accuracy, 385 words per minute, or 385, correct words, and 401 words per minute. I'm in the top 1% because I'm just that good. And I get to share the screenshot with everybody in the company and saying that I'm the fastest there. So now this is a silly example, but this just goes to show what all you can do with Selenium, right? If you can do something this zany and out there, what else can you have access to? If you have access to, going back to even another DNS example, if you have all your DNS and a DNS provider who doesn't allow you to export your DNS, but you need desperately to move out of them, how else do you get that DNS out? Unless you're sitting there clicking and copying and pasting for the next 3 hours. With Selenium, you can go through, find out what those patterns are in the page, rip out just the data that you need, and throw that all out to an Excel sheet. It's really super simple, really quick, and it, like I said, it's still temperamental. You still have to work with it where you can, but yeah, it makes things a lot easier and gives you a lot more expandability and options than you would normally have. So if we close this out, we go back to our presentation. So that's all really cool. We know how to now interact with APIs. We know how to interact with websites that don't have APIs and still get data out and interact with web pages. But what happens if we wanted to build our own websites, right? Well, you can inside of PowerShell using something called PowerShell Universal. PowerShell Universal is a super, super powerful tool. It's expanded even leaps and bounds in the years that I've been using it. Basically, what it is, it allows you to build full React applications in PowerShell using PowerShell code for the front end, executing PowerShell code for functions and methods within the web app. Everything happens in PowerShell, and your only interaction with the app is through PowerShell, unless you wanted to go farther. So like I said, it's a full .NET Core app. It can be hosted in any cloud provider. Specifically, we're an Azure shop, so I've deployed this to an Azure app service. But this works equally as well with AWS. Even if you wanted to run just an A.A.S server locally, everything, there are plentiful guides on how to deploy this anywhere that you'd ever want to use it. It's highly customizable, so you can go as deep into the code as you want. Like I said, by default, you're only working with PowerShell and this PowerShell code, and then the utilities and things that they allow and give you pre-built. For most people, that's probably going to be all you'll ever need for. If you're just basically making a basic front end for your PowerShell scripts, things that you use on a daily basis, this is a really great way to give a web-hosted front end and a graphical user interface for any employees or anybody who would need to use it without having to actually run PowerShell scripts on their machine, which requires some level of familiarity with PowerShell. So yeah, let's jump into it and show a quick demo. And like I said, this has actually expanded just immensely since I've used it. So it was about 2 years ago when we implemented this for a Active Directory management utility, basically onboarding, offboarding, so that we could use whenever a new employee is onboarded, we have, X number of tasks that need to happen at the same time. All of that was already written in PowerShell. We're doing all of it manually. How can we make this a nice, pretty front end to still use all those same connections and things that we built up over this entire time? PowerShell Universal is a great example of that. Great use case for that. So let's see if we advance on here, and I'll show you just the basic little dashboard that I've built here. So let me move over and I'll give you a tour of what PowerShell Universal is. So this is now what PowerShell Universal looks like. This is a quick and easy install MSI. You'll see it's running on localhost 5000 currently. This is running through PowerShell. It's running as a service right now called PowerShell Universal. I will note first for licensing issues and pricing, it's not free. It's quote unquote free for community and learning utilities. But by the time you start moving into needing authentication and other things like that, you will have to pay. It's gotten a little bit pricier. It's about $50 a month now for enterprise customers. I think it's around 10 for individual use. So something to keep in mind there. But for the power of what you're getting, it is amazing. So this is the main web hosted interface that you're going to interact with PowerShell Universal in. They do have a lot of other utilities and options in here as well. You can even host your own APIs in here with your own authorization and things. You can use automation, basically just a really advanced scheduled jobs runner or cron job runner for PowerShell, and can run everything on its own. But specifically what we're targeting here and what we're interested in are dashboards. So they also have pages, which are a little bit less advanced, and for some use cases can be great. It's just, here's a single page application. I just need to enter some data on this form, pass it to PowerShell script, and it runs. But so if we go down to dashboards here, I currently have just one test dashboard, presentation dashboard built. And if we click view button here, we can really very quickly go to it. And this is all running in PowerShell. That's something that's, kind of hard to wrap your mind around at first. Keep that in mind. Everything that you're seeing here is operated off of PowerShell. So all I'm running to get this field populated, this entire screen populated, is get process. So get process just shows you the current processes that are running on your machine. In this case, I have a whole lot of processes running on my machine. And all I've done for this quick example is just to be able to kill the processes that I select. So if I go through here and select, say, 2 of these, because I don't care if Adobe dies, stop selected processes, successfully stop the following processes. See that they now disappear from this list, and I can even open Task Manager. And let's see if I can find Adobe in here. There we go, Adobe CEF filter. It'll restart on its own because Adobe's very aggressive, but they did disappear, and you'll see them disappear here with different process IDs. If we clear this again, those are now gone. So that's all happening in PowerShell. Now, if we want to look at what that code actually looks like and how we built this dashboard, we can go back here to PowerShell Universal, quickly click the edit button, click the details button, and we'll see the code behind that dashboard that actually built the dashboard. So it can look a little bit daunting at first when you first look at it, but this is really basic. And at the end of the day, all we're doing here is we're finding first a new dashboard here with new dashboard. That's what ultimately going to be the containing object for everything on the site, right? Below that, we have this new UD dynamic. And all this is it's a region of your page that you want to be updatable. You don't want to be static, and you want to change. The reason that we're doing this for the table is we want the table to update whenever we click the stop select processes button. We want to reload the table so we get newest, freshest data to see if the process actually stopped. All we're doing next is we're going down here to populate this data field, is this get process. So get process, and we're selecting out just the objects that we want out of here, or excuse me, just the columns that we want out of here. So all I care about is the name, the ID, the CPU usage, and whether or not the process is exited. You can go over here, we can see that we've got the process ID, process name, CPU, and is running. Now that we have the data that we care about, we can go down here and populate this quick columns variable. Columns are defining inside the table the data that we care about. So we're saying we want to rename, in this case, ID to process ID, giving some tertiary data here with all these switches of whether you want to show and sort and other things like that. You don't have to care about that for all we care about now. After we populate our columns, we can go down here and create our actual table. This is what's ultimately defining what we're seeing over here. We're creating just a process table, passing in the data that we created above, as well as the columns above. And then we're saying we want to paginate it with page size of 10. Now down here is the cool part where you're actually interacting with PowerShell, right? So this is what's happening after we click the Stop Selected Processes button. It first goes and gets a list of all of the selected rows that you selected out of the table. It iterates through each of those. It attempts to stop the process with a row ID, forcing it. If successful, we get a nice little toast message saying stop, polling process was stopped. If for some reason it's not able to, we get unable to follow to stop polling process. And then no matter what, we want to resync the table so we get the newest, freshest data for the processes table. All of that, this small 32 lines of code, built this entire true web application, right? This can be hosted anywhere. This can be hosted on a true endpoint, public facing, that has all of this data, everything accessible to you. This is just a tiny example of what all you can do with this. With any existing PowerShell modules or connections that you have, you can now have this beautiful front end for them that gives you options that you wouldn't even have typically in PowerShell, unless you built a GUI around it. It gives you tons and tons and tons of expandability options. And like I said, this is just one small example. And like I said, now this is just the free version, so there's some things missing. You don't have modules and rate limits, things like that you only get in the paid version. But for this, it's perfectly acceptable just to show off what all PowerShell Universal can do. And like I said, this is not just one portion of the dashboards is just one portion of PowerShell Universal. There's this entire other suite of utilities that you get in here as well. So very interesting and very cool thing to check out, especially if you have any existing infrastructure with built on PowerShell. And so with that, I hope you all have hopefully gotten something out of all this tonight. Learned a little bit something new that you've not learned before, didn't know that PowerShell could do, and see all the possibilities and flexibility that's available to you. And so with that, I will leave you with my contact info. And I hope you all had a great night.
Thank you, Eric.
You can go ahead. Yeah, I'm sending back over.
Yeah.